In this lesson, I'm going to be going over some examples of how we can use the reference circle to solve problems. So, using phasors to solve problems in SHM. Okay. So we're going to look at a couple of examples, so 3 different examples of how we can use what we've learned about phasors to solve problems. And solving these problems is basically predicting either how far, or predicting the position of an object at a particular time, or predicting how long it will take to get to a particular position. So what we'll do is we'll have a look at this first problem here. I'll just drag it over and resize it and then zoom in a little bit. Let's pop this problem here and then resize it a bit so that we can see what's going on, and then we'll zoom in. So we have this baby on a kind of baby bouncer toy, and we're told that she travels 0.8 meters every oscillation and does 30 oscillations every minute. So our first challenge is to calculate her amplitude and period. So we'll do that first. In fact, okay, so amplitude, if she travels 0.8 meters every oscillation, that means she's going to go, in one oscillation she's going to go down and then back up and then up and then back down. So 1 amplitude, 2 amplitudes, 3 amplitudes, 4 amplitudes. So 4A is going to be equal to 0.8 meters, which means that A is equal to 0.200 meters. And we're told that she does 30 oscillations per minute. So the time period, well, she takes 60 seconds to do 30. So therefore the time period must be 2 seconds. So if it takes 60 seconds to do 30 oscillations, it must take 2 seconds to do 1. I might give that to a few more significant figures. 2.0, given that 30 was given to 2. Okay. Second question. How far from the floor will she go in 0.5 seconds? So here we could quickly sketch a reference circle. And this is quite a simple problem. She's going to start, we're talking from the floor. So if we're going from the floor, then the phasor is going to start off pointing downwards. And 0.5 seconds is exactly 1/4 of a period. So she's going to go to there. So this one is a very easy problem because she's going to travel exactly so she's going to go from this position to this position, which is exactly 1 amplitude. So we don't need to do any calculations for this one. So the answer is just 0.200 meters, because every quarter cycle the object will complete 1 amplitude's worth of motion. Okay, so third question. How far from the floor is she 1.2 seconds after leaving it? Okay, and we'll ignore this advice and just imagine we're working from scratch here. So we'll draw a slightly bigger reference circle because we're going to need to do some detail in this one. And I might just move that so it's centered a bit better. Will it let me do that? No, it's clipping onto things. I'll just pop it there. That's okay. So it's going to start. So here's the center of our reference. Oops. Here's the center of our reference circle. So we want to find out how far from the floor she is 1.2 seconds after leaving it. So we'll draw the starting phasor, which is downwards because she's at the floor to begin with. So she's at this lowest point. And we know that after half a second she'll be there. After 1 second she'll be at the top. And after 1.5 seconds she'll be here. So she will be somewhere around here. Okay. And we want to know how far from the floor she is. So we want to know, basically, that's where she'll be We want to know what this whole distance is. Okay, so if we look at this diagram here, we know that the bottom part of this distance, so this distance here, is 0.2. We then need to just figure out how much we need to add to that to figure out how far she is from the floor. So to do that, what we can do is just we'll draw a little dotted line here going vertically upwards, and then another dotted line here, and the distance that we're interested in finding is this one. And we know that this distance here, because this was 1 second here, so this whole thing here took 1 second. So here is 0.2 seconds worth of spinning. So we need to first find omega, so this is omega t. And our little green t here is 0.2 seconds. Because she's gone for 1.2 seconds. If this whole bit took 1 second, which is how long it takes to go through half a cycle, then this little extra bit has got to just be another 2 seconds. Omega is 2 pi over t, which is 2 pi over 2, which is just pi. And so the angle there, omega t, which is equal to our little angle here, I'll call it theta, is going to be equal to 0.2 pi. Okay, and now if we look at this triangle here, what we're interested in is this value x here. And that value x, that's the adjacent side in this triangle, and we know that the length of the phasor is a, which was 0.2 meters. And so we can say that x over 0.2 is equal to, well, adjacent divided by hypotenuse should be cosine of theta. Cosine of theta, but theta was 0.2 pi. So x is equal to 0.2 times the cosine of 0.2 pi. So 0.2 times 0.2 times pi, and then we'll take the cosine of that, and we get 0.1618 equals 0.1618 meters. Okay, so now we know that that green line here is 0.1618, but we were asked how far she was from the floor, so we need to add 0.2 to that. So she is 0.2 plus 0.1618 meters from the floor, i.e. 0.36 meters to two significant figures. Okay, so sometimes with these reference circles, you need to interpret the information quite carefully in order to figure out just what distance it is that's most useful to figure.